Welcome to Science HQ. My name is Makoligo, and in this video I'm going to show the mechanism of free radical substitution reaction that occur between alkane, a substitution reaction that occur between alkane and the halogens. So halogens means group 7 elements. Zile group 7 element ndio tunaziita halogens. And the halogens, it means the ability of forming salt, of those elements that can form salt when they react with metal. Ukichukua mfano sodium, which is a metal, plus chlorine, this one it is a salt. So halogens means ability of forming salt. Okay, so now we are going to see a mechanism of substitution reaction that occur between alkane, which is a saturated hydrocarbons, and halogens. But this mechanism needs some conditions, and this condition include high temperature or ultraviolet light. Ultraviolet light. So we can find a reasoning why we prefer to use these conditions. We know that this is alkane, which is a saturated. Saturated means it contains maximum number of hydrogen in each carbon. That is number one. And number two, alkane, it is made by sigma bond here. Sigma bond, sigma bond, sigma bond, sigma bond. And we know that sigma bond, it is a very strong bond that is formed by head-to-head overlapping of atomic orbit. So if you want to perform a substitution reaction, means that you need to break the sigma bond. You have to break the sigma bond. So because this bond is very strong, that's why we need to use high temperature or ultraviolet light. So these conditions is to idea to break this bond. So in order to break a sigma bond, you need to use either high temperature or ultraviolet light. So these two conditions are very important. In other words, we can say this mechanism cannot occur at darkness and low temperature. At darkness and the low temperature. So this reaction cannot occur at darkness and low temperature because itakuwa hard kuweza kubreak hizi sigma bond by darkness or low temperature. That's why we prefer this high temperature or ultraviolet light. So those are two conditions. But also, this mechanism involves 3 steps. Step number 1 we call initiation step or initial step. Number 2 it is called a propagation step. And number 3 it is called termination step. Termination step. So the first one, which is initial step or initiation step, here it involves formation of radicals. And here in propagation, we are going to see a reaction between molecule plus radical. And for termination step, which is the last step, we are going to see a reaction between radical plus radical to form molecule. So hiyo mechanism inakuwa involve hizo step kuu tatu. So starting by number 1, which is initial step, initiation step, we said this involves formation of radicals. So you take any member of halogens. Let's say we are going to use chlorine. So this chlorine we need to, it's like to write chlorine. Then after we need to use, let's say, ultraviolet light, and the function of UV light is just to break this bond homolytically. Means every single chlorine will retain one electron from bond breaking. So here you will have chlorine radical. So here in your initial step, which is formation of radical, now we have these radicals. So now we go to propagation step. It is where you are going to reacting alkane, like this one, plus, we said it is a molecule plus radical, so you take a radical, which is chlorine radical, and then we put UV light. So this, we can light this alkane in open form, like, so hydrogen, plus a radical. What will happen? So this bond here between carbon and hydrogen, which is a sigma bond, it will break homolytically. Means you will get CH3 radical, and then you will have hydrogen radical plus chlorine radical. So radical and radical will react to form HCl. So you will start by this one, which is CH3 radical plus HCl. So that is the first step of propagation. And then we proceed with propagation. So in propagation, we said it is a reaction between molecule and the radical. So now we take this one, carbon radical. So this one, it is radical. So you take a molecule of chlorine, 2 chlorine, and then you put UV. This helps to break this bond homolytically. At the end, you'll have chlorine radical. And then this chlorine will join here. So utakuwa na carbon, hydrogen, chlorine, plus this one, chlorine radical. And then you proceed with propagation step, a reaction between molecule and the radical. So you can take this one. So here it is chlorine, carbon, hydrogen. Here chlorine, una hydrogen. So this one, it is a molecule plus radical. You take this one. So here you put in UV. And then now we are going to substitute this one. So we have to break this bond homolytically. So you will have CH2 chlorine, here it is radical, and then you have a hydrogen radical plus chlorine radical. And then this one will join to form HCl, and you will have this one, CH2 radical Cl. And then we proceed with propagation, a reaction between molecule and the radical. So you take this one as a radical, C, radical here, chlorine, hydrogen. So this acts as a radical plus molecule. So molecule will be 2 chlorine. And then you put in UV. We get here radical. So this chlorine join here. You'll have carbon, hydrogen, chlorine plus chlorine radical. You see, then you proceed with propagation tena. Unafanya propagation nyingine. So you propagation molecule and radical. You take this one as a molecule, which is carbon, chlorine, hydrogen plus radical, and then you put UV light, and then now we need to break this bond homolytically. So you will have CH radical, 2 chlorine, then hydrogen radical plus chlorine radical. This one will join to form HCl plus, here it is CH2 chlorine radical. You see? And then you proceed with propagation step. Propagation step. So you take this one as a radical, which is, sorry, here it is CH chlorine 2 C H, here it is radical chlorine. So this one, it is a radical plus molecule, you see? And then you put here, you trivialate, right? Chlorine radical. So this radical will come at this point, and then you will have carbon, chlorine, hydrogen, chlorine, plus this radical you put here. And then you proceed with propagation. Propagation means molecule plus radical. So you take this one as a molecule plus radical. Here you put UV, right? That helps to break this bond homolytically. Pap. So carbon, Cl3 radical, and then you have hydrogen radical plus chlorine radical. You see? So here it will be HCl plus carbon Cl3 radical. So you go the final step of propagation. Hapo ndio kufanya propagation kwa mara mwisho. So you will take this one, carbon, chlorine radical plus a molecule of Cl. Here it is UV, then you have chlorine. So this will form another bond. So now it is carbon, how many chlorine? Chlorine 1, chlorine 2, chlorine 3, chlorine 4 plus radical. You see? So now we have CCl4. So then we go for termination step. Termination step. So it is where you take radical plus radical. So you take this radical plus radical to form a molecule. So you take the same radical. Utapata this one. So the end product, it will be CCl4 plus, you see? Hii ndio mechanism ya free radical substitution reaction inayofanyika katika halogens pamoja na alkane. So naweza nikasummarize kwamba ili uweze kufanya substitution ya alkane pamoja na halogens ni lazima uweze kutumia harsh conditions like high temperature pamoja or UV. Na aim ni kuweza kutusaidia kuweza kubreak zile bond between zinazopatikana kwenye alkane, because alkane inakuwa made by sigma bond na bond ambazo ziko very strong sana. Kwa hiyo ili uweze kuiforce alkane iweze kufanya reaction lazima uweze kutumia hizo conditions. Lakini pia cha kuweka to put in mind is that for alkane it is very hard kuweza kuperform hizo substitution reaction at room temperature and darkness. Haitawezekana kwa sababu zile bond hazitaweza kubreak. So those are two conditions. Then after ni lazima uweze kuelewa kwamba that mechanism inakuwa ina involve step 3. Step ya kwanza tunaita initial step or initiation step, ambayo hiyo step ina involve formation of radicals. Kama utakuwa umetumia chlorine molecules, utatumia UV ili uweze kupata zile radical mbili za chlorine. Kama utakuwa umetumia bromine, fluorine and iodine, ni wewe utachoamua kutumia ni kitu gani. Then after tutaenda kwenye step ya pili ambapo tunafanya propagation step. Hapo unaenda kujoin between radical and molecule, radical and molecules, na utaifanya hiyo reaction mpaka pale ambapo zile hydrogen zitakuwa zimeisha kwenye upande wa alkane. Hapo ndio propagation inapoishia. And then kwenye radicals, kwenye termination, it is where you are going to see the reaction between radicals. Unachukua radical plus radical. Ile radical ambayo itakuwa imebakia pale kwenye step ya mwisho ya propagation inabidi uweze kuifunga. So utaichukua yenyewe una plus na nyingine. And then mechanism yako itakuwa imekamilika. Kwa hiyo ambaye bado hujasubscribe mpaka sasa hivi, nakushauri kuweza kusubscribe, kulike, kucomment, lakini pia share video hii kwa watu wengi zaidi ili waweze kupata maarifa haya. Karibu sana katika Science HQ, nami utajifunza vingi sana kupitia channel hii. Thank you so much.